Hi, I'm Ryan, and today we're gonna talk in general way about solids, liquids, and gases. So today we're gonna talk in general about solids. Now let's take neon as an example. See here, this is a solid. The particles move back and forth and they are in slow motion, and they are really close together, and the attractive force between the particles is very strong. But when the but when the temperature increases, the particles move faster, 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 faster. And then now it's kind of a liquid, and when we move it with more heat, now look, it's becoming a gas. So let's go back to the solid. So this is now solid. Let's take also a skateboard for example. When you ride your skateboard to the supermarket, does it change? Its volume change? Its size change? Does um, its mass change? No. Why? Because the particles are really close together, and the attraction force is very strong. It's very strong. Now, the rest of the details we're gonna talk about it in next videos. So now let's go to liquids. Liquids are in general like liquids are a liquid. Liquids are particles that move faster than solids and less than gases. They are not that close together, but they have a definite shape and no definite have they have a definite volume. Sorry, they have a definite volume but no definite shape. The gases have definite shape and definite volume because they are close together. Here they don't the water they don't have a definite shape, but they have a definite volume. That's why they have an ability to take the shape of the container. Now we're gonna move them faster. Now you see, now when we cool them back, the particles come closer together and they come back as a liquid. So liquids move faster than solids and they have no definite shape, but they have a definite volume, which helps them to take the shape of the container. The attractive force between the particles is weaker than the attractive force weaker than the attractive force between the solids, and they can slip past each other. Now let's go, and the details we're gonna talk about it in next videos, same as the solids and the gases. Now let's go to gas. See now the difference between the gas, the liquid, and the solid. See the difference between solid and gas. See how the distance is great between the particles. It's very great, and the attraction force between the particles is very, very weak or absent. It's even absent. So the attraction force between them is very weak or absent, and they move very fast. They move faster than liquids, and liquids, and they don't have a definite shape or definite volume. That's what makes gas also in everywhere. The forces between the particles is very weak or absent. That's what I said before a little bit. And the particles, and when you move from a solid state to a liquid state, the particles move faster. And when you move from a liquid state to a gas state, the particles move even faster. And when when a particle of a liquid or a solid or a gas collide with another particle, it changes its direction and speed. Now look, if I heated it up, it will move faster, faster and faster. Let's see. See the difference? Now, if I go to solid and heat it up, heat it up. Look at the particles, how they're moving faster. Look, now they're liquid. They now started to change to gas, and now look how fast they are. You see, they are very fast, and the distance is becoming greater and greater and greater, and the attractive force between the particles is becoming very weak, and there's a point that the attractive force between the particles becomes absent. So, like this, we've finished for today, and we'll talk in more details next videos. See you later.